Welcome back to your lighting and electrical training series. In this lesson, we're going to take a step back and look at the bigger picture, how lighting systems get their power. To understand that, you need to first understand the basics of the electrical system. Even though this might sound technical, don't worry, we'll break it all down in simple terms. Whether you're just starting out in the trade or getting ready to work your first real job, this is information you'll use every single day. Let's get started. Let's begin with the most basic question. What is electricity? Electricity is a form of energy. It is created by the movement of very small particles called electrons. You can think of electrons like tiny invisible runners. When they move in a specific direction, like in a wire, they create electric current. So when we talk about electricity flowing, we are really talking about electrons moving through a path or a circuit. This flow of energy powers our tools, appliances, and of course our lighting systems. Now that we know what electricity is, let's talk about electrical systems. An electrical system is any setup that takes electrical energy and turns it into some kind of work. That work could be turning a fan, running a motor, charging your phone, or lighting up a room. In lighting systems, the work output is illumination, the light you see. Just like motors and fans, lighting systems require electric power to function. That power doesn't come from nowhere. It is delivered through the building's electrical system. That's why, as a lighting technician or electrical apprentice, you are not just working with lights, you are working with electricity and how it flows through the system. So where does that power actually come from? Let's follow the flow. Electricity is created at a generator. This could be a power plant or a local source like a solar panel or a backup generator. That electricity flows into the building through a main service line. Inside the building, it goes through distribution equipment, like breaker panels. From there, it moves into individual circuits, including lighting circuits, which power your luminaires. You can think of this flow like water through pipes. The generator is the reservoir, the wires are the pipes, and the lighting system is the faucet at the end, releasing light instead of water. To guide that electricity safely and efficiently, we need materials that let it flow, and some that stop it from flowing. A conductor is a material that electricity can easily pass through. An insulator is a material that blocks electricity. Copper is one of the best conductors. That is why it's used in most electrical wiring. It lets electrons move freely and easily. On the other hand, plastic, wood, and glass are all insulators. They keep electricity from escaping the wires and going places it shouldn't. So the wires in a building are made of copper conductors covered in plastic insulation, keeping the flow controlled and safe. Now let's break down a word you've heard a lot so far, a circuit. A circuit is a complete loop that lets electricity flow from a power source through a device like a light and back to the source. Imagine it like a racetrack. The power starts at the generator. It goes through the wires to your light fixture. Then it returns back to the generator to start the loop again. When you flip a switch, you are opening or closing that racetrack. Open circuit equals no flow equals light is off. Closed circuit equals electricity flows equals light turns on. Now that we understand what a circuit is, let's talk about lighting circuits. Lighting systems don't just connect anywhere in the building's wiring. They are usually wired to their own dedicated circuits. Why? Because lighting has its own power needs, known as the lighting load. The lighting load is the total amount of electricity used by the lamps, ballast, and fixtures on that circuit. It is measured in watts. Each lighting circuit has limits, just like a water pipe has a limit of how much water can flow through it without bursting. The limits are based on the size of the wire. Thicker wires carry more power. The wattage of the lights. The breaker size, which protects the circuit from overloading. A good technician knows how many luminaires can be safely connected to a single circuit based on these factors. Let's pause for a quick review of important terms you'll want to remember. Electricity, energy created by moving electrons. Circuit, a complete loop that electricity flows through. Conductor, a material like copper that lets electricity flow. Insulator, a material like plastic that blocks electricity. Current, the rate at which electricity flows through a circuit. Voltage, the pressure pushing the electricity through. Resistance, what tries to slow the flow down. Lighting load, total wattage of the lighting on a circuit. These are the building blocks of electrical work. Master these and you will have a solid foundation to build on. Let's wrap it up with a big picture. Electricity flows from a generator into the building's main panel through lighting circuits made of conductors and into lighting systems which convert that energy into light. Lighting circuits must be carefully designed to match the load of the system, using the right wire size, circuit breaker, and the number of luminaires. And all of this depends on understanding of how electricity works, from electrons to conductors to circuits. You have just taken a huge step in your training. Understanding how electrical systems work is the key to safely and confidently working with the lighting systems. And this knowledge will guide you on every job site. I will see you in the next lesson. Until then, keep learning, stay safe, and remember, you're not just working with lights, you're managing power. Thanks for listening.